I'm going to demonstrate a sensory substitution device which I recently worked on, and it's actually running on Raspberry Pi and running a bunch of edge impulse inference engine to classify different voice and images. And whenever it classifies something, it actually sends the haptic feedback to the Neosensory bus. And now the idea is that once the classification is done and something is recognized, it will send the haptic feedback to the buzz, and using sensing that vibration on the wrist, user would know what actually happening around him or her. Just for example, suppose a person who actually struggles to classify different human gestures, or I would say different sign languages. So this device will actually classify those things. For example, if the sign says sleep or thank you or sorry, like regular American Sign Language, right? And then after classification, it will actually send a predefined pattern to the Neosensory bus. And before that, we assume the user is actually trained with different haptic feedback so that user knows what exactly that particular vibration pattern means. And that's actually part of brain plasticity. So if you do some research around that, you'll be amazed how human brain works. So when we train a person with different haptic feedback, very soon our brain will actually rewire different neural paths, and it will just behave like a new sense. Okay, so along with this tiny device, I have written an app using which I'll be training my users. So let me open the app. Okay, so this is the app I have created, and it has, this is basically the dashboard, and you can see it's actually connected to the bus, and you can see the bus serial number and the device name and the remaining battery life, everything coming from the bus directly. And I have a page for training, so let me go there. And I have different modes. So for this demonstration purpose, I am just going to train her for different sign languages. So let me click on that. So I have couple of signs. For example, you can see sleep, please, thank you, and drink. So I'm actually going to train her on two different sign languages. One is sleep, the other is thank you. And one more thing, like you have to trust me that it's actually sending some vibration to this buzz, because you can't really see. But I believe there will be little sound, probably that will prove it's actually working. So let's try. So you ready?
Yeah.
All right. So as I said, I'm going to train her on sleep and thank you. So as soon as I press this button, it actually sends the feedback, and she should actually feel that. So let's get started. So first is sleep.
Okay. Okay.
Thank you.
All right.
Can you just bring your buzz a little closer so that we can hear the sound if there is any? Again, sleep. Again, sleep.
Okay.
Thank you.
Got it.
Thank you.
Got it.
Thank you. Sleep.
Got it.
Got it?
Yeah.
Okay, and so let's do a little quiz.
Yes.
Right? So I'm going to buzz some, and you have to tell me what is that.
All right. Thank you.
No, it was sleep.
One second, can I?
Yes, sure. One more time.
That's thank you.
That was sleep.
I need to test again. I need to practice.
Okay, a little more.
Yeah.
Let's do it. So, sleep.
Okay.
Thank you.
Okay. Got it.
Sleep.
Okay.
Thank you.
Okay.
Sleep. Thank you.
Go.
Okay, so ready for quiz?
Yes.
Okay, let's get started.
Sleep.
Very good.
Thank you.
Very good.
Sleep. Sleep.
Very good.
Thank you.
Very good. So you can see how quickly human brain can actually train, and it actually created new neural paths, right, in your brain, and it can actually recognize different things. So now what we'll do, we'll actually run it through the device. Because what you have seen is basically just the training. I was actually creating different vibration pattern on the wristband from the app. Now we're going to do exact same thing, but that time it will be through the device camera. So camera will capture my gesture, and then it will run it through the edge impulse inference engine, and it will classify what gesture I'm actually showing, and then it will actually send the feedback to the wristband, and she should be able to tell us what my gesture was. So what I would do, because I don't want her to see me, I'll request my daughter to turn around, and I will actually start showing the gesture in front of the camera, and she will say it loud when you hear something. One more thing I wanted to point out, because this particular device which I built, it can actually have multiple modes. So currently I have 4 different modes. One is recognize snoring, and based on your snoring, it can actually send you some feedback. That's very useful for different scenarios. Please check out my hackster IF project for detailed explanation of each and every modes. But right now, for our demonstration purpose, we are going to focus on American Sign Language. So for that, you can actually change your device to a particular mode. So I just tapped on sign language mode, and now our device should be able to classify different sign language. Okay, so I changed my position a bit, and I'm going to show different gestures and see if my daughter can actually recognize those.
Thank you. Thank you. Sleep.
Very good. So you can see, like I was showing 2 different gestures, sleep and thank you, and it was actually sending the feedback, and she was able to recognize those. So yeah, so that concludes my demo, and I hope it inspires you. You can think about all different possibilities using the Neosensory buzz and edge impulse. Thanks for watching. Bye.